All right, everybody, let's continue on with our discussion of t-tests. We're going to get into the second kind of t-test in this video called the independent samples t-test. All right, so let's jump right into it, and we'll start with talking about the what and the when. So the independent samples t-test, also called the two-sample t-test, is when you want to look at the look to see if there is a significant difference between two sample means, which are independent of each other. That's a key thing here. So here we've got two separate and unrelated groups. That's when we would use an independent samples t-test. When I have a one sample and one mean, and I want to compare it to a population, that's a one sample t-test. Those are my two means that sample the population. Well, what if I want to compare two means to each other? I want to see if the mean from sample one is different from the mean of sample two, right? And so also these two groups are different from each other. They are unrelated, they are independent, two completely different groups of people. So that's the scenario in which I would use an independent samples t-test. So I've got two separate and unrelated groups. I got a mean in each group, and I want to compare those two group means to each other. So let's say for our scenario that we're going to work with in this section, are psychology majors more intelligent than philosophy majors, right? Let's say I want to compare the IQs of students of both those majors. So let's take our general question. Let's specify a little bit more. Do psychology majors have a significantly higher average IQ than philosophy majors' average IQ? Here are some things about it that indicate, about the question indicating independent samples t-test is required. So you're looking for a difference between only two groups. So you've got your two groups mentioned here. First group is psychology majors, second group is philosophy majors. So that indicates a t-test, right? You got two groups, two things being compared. You're examining the difference between the means, okay? So for this one, the specification is higher, right? It's not just a difference, but a specific difference. Hint, hint, it's probably a directional question, okay? So it's specifying the difference between the means. And then you've got, of course, averages indicating means are what you're working with. And then lastly, you have two separate and unrelated groups are being compared. You would know this from the context of the research if this data is coming from two independent groups from each other, right? So our two groups we have here are psychology and philosophy majors. Okay, so again, we have two groups, unrelated groups to each other, and we're comparing their averages. So our variables for an independent samples t-test, we have two specific variables, but they're not just simply an x and a y. Now we're going to introduce some terms called a dependent variable and an independent variable. And specifically with an independent samples t-test, we want to see is if there is a difference in the dependent variable based upon the independent variable, okay? So how do we identify which one is which? Well, your independent variable is your groups, okay? So what are our groups here that we have? Well, they would be psychology and philosophy majors. So majors would be the groups here. So the independent variable is categorical because it is our groups. So specifically our groups are psychology / philosophy. Remember, the slash indicates categorical measurement. So major is our independent variable, and we have measured major by two measurements, psychology and philosophy. Now, what is our dependent variable? What are we trying to see is different between our two groups of psych and philosophy majors? Well, that would be average IQ. Remember, so for you to know, the dependent variable is the thing that you are averaging. It is the thing that you are calculating something on. So in this case, it would be IQ scores, and it is continuous. And the way that you would know its scale is based on the measurement. That would be clear in the data of some sort. So let's say that our IQ measurement is going to be ranging from 70 to an IQ of 180, right? So we're going to look at the average, and the average should fall between this range here of numbers. So we've got a categorical and a continuous variable. The independent variable is categorical because that's our groups, and the dependent variable is IQ scores. It's continuous because we're calculating an average. So that's how we have our variables set up here. Now, how do we actually calculate the t-score? Well, remember, the t-score always represents the same thing for every t-test, but the calculation is slightly different. The top part of the t-equation for the independent samples t-test is the difference between the means. Just like it was in the one sample. The top part is the difference between the means. Here, it's the difference between the mean of sample 1, indicated by the subscript 1, and the mean of sample 2, indicated by subscript 2. Now, the bottom part is still the measurement of sampling error. The top is always the difference, the bottom is always error. Now, in this case, with the independent samples t-test, it is a measurement of standard error, and it's specifically called the standard error of a difference between the means. Think about it this way. You're essentially taking the standard error of sample 1 plus the sample error of sample 2, and then you add them together and square root them, so to speak. That's essentially what you're doing here. So that's what that bottom part is. It is factoring in the sampling error from both samples. Because remember, every time you have a sample, you have sampling error. So if we've got two samples here, two unrelated groups, there's two different sampling errors that we have. One for the first group, one for the second group. We have to factor them both in when calculating our t-score. And so that's what this bottom part is doing. And the t-score represents the same thing that it did with the one sample. It is representing the difference between our two group means while also factoring in sampling error. In an independent samples t-test, it's representing the difference between our two sample means specifically. Okay, so let's put this together, start putting together our scenario. Let's say that you gave 12 students an intelligence questionnaire. 6 of these 12 students were psych majors, the other 6 are philosophy majors, and you can see their IQ scores there listed in the table in the upper right. So in order to calculate our t-score, we've got to put a few things together, right? So I've given the standard errors just so we can just have those moving forward. So now what we need to do is find our sample sizes, we need to calculate our means, and then we need to calculate the standard error there, so then we can finally calculate our t-score, okay? So here is our means. We have a mean for psych majors of 132, we have a mean of philosophy majors 96.5, sample size is 6 in both groups. So now we can take the numbers that we have here, and we can calculate what we need to. So pause the video and try to calculate the standard error of a difference between means and also the t-score. So what you should have gotten is a standard error of a difference between means of 10.658. That's based on the standard error for both samples. Then we can take that and we can put it into our t equation, and we get 132 minus 96.5, the difference between our means on top. We have standard error on the bottom, and we get a t-score of 3.330. Okay, so that's our t-score. That's representing how different our average IQs of our groups are, also factoring in how much sampling error we have. Now notice sampling error is 10.658. That's pretty high. Okay, so you've got a lot of sampling error here in this calculation here. So remember that a bigger t-score indicates a bigger difference between the means. So with an independent samples t-test, the bigger t-score would represent a bigger difference between our two group means. So a bigger difference between psychology and philosophy majors' average IQ. Okay. Now we do have a large amount of sampling error, so maybe the difference is actually bigger, but the sampling error is bringing our t-score down, so it's not representing the difference as big as it should be. Okay, so we got to keep that in mind. Sampling error might lead to this t-test being resulting in a non-significant difference. Okay, so in the next video, we're going to look at independent samples t-test applied with hypothesis testing.